Hello, distinguished viewers. Welcome to Simplified Maths Class. Simplified Maths Class, it has always been. And today, once again, we are going to be taking Longitude and Latitude Part 2. Before we proceed, please, if you have not subscribed to our videos, please click on the subscription and then click on the bell notification. And God bless you as you do that. Once again, my name is Mr. Mike Omeni. And then in this second aspect of longitude and latitude, we'll be going straight to the small circles. Why? Because in the previous slide, we talked about the great circles. After the introductory aspect of longitude and latitude, we were able to solve problems that involved the great circles, which is the meridians of longitude. And so today we'll be solving problems that involves the small circles, which is the parallels of latitude. And without waste of time, the problem is on the board here. Let's see how we can handle that. It said an aeroplane flew from town P, which is on 40 degrees west, 60 degrees north, to another town Q, which is on 10 degrees west, 60 degrees north. And it took the plane 10 hours to arrive its destination. So you should find or calculate the speed of the aircraft in kilometers per hour. And of course, before we calculate the speed, we have to first calculate the distance between the two towns P and Q, measured along the small circles, which is the parallels of latitude. All right, so let's go straight to solving this problem. So we have our north, south, east, and west. And they say the plane flew from town P, 40 degrees west. So the west is the longitudinal lines. So we are going to take 40 degrees west. So this is our 40 degrees west. And then 60 degrees north. Okay, let's take here to be the 60 degrees north. So that's our 60 degrees north. So the intersection of the longitude and the latitude line gives you the town P. Now to another town Q, which is on 10 degrees west. So this is our 10 degrees west, another longitude line. So let's take that as 10 degrees west. But on that same latitude, this same 60 degrees north. All right. So the intersection of this longitude and the latitude gives you the second town Q. So we want to first calculate the distance from P to Q. And if you look at the distance from P to Q, it is measured along the small circle, which is the parallels of latitude. All right. So the distance PQ, is given by the formula theta all over 360 times 2 pi is small r. But understand that small r has a value, which is big R, the cos angle of phi. That's the value of the small r. All right, so we are going to substitute the small r with this. So, but don't forget, small arrow it is, because we are dealing with a small circle. In the previous example, we're using big arrow direct, which is a great circle. All right, so we are going to have the distance PQ now will be equals to theta all over 360 times 2 pi. So instead of the small arrow, we use big arrow, the cos angle of phi. All right, so what is theta? Our theta is the difference in longitude. All right, so there are differences in longitude. But when we dealt with the small circles, before now, the great circles, the theta was the difference in latitude. But in the small circles, the theta is the difference in longitude. All right, so the difference in longitude, we had 40 degrees west. That's the longitudinal line. And then we have 10 degrees west. All right, so west-west, we subtract. Why? Because like terms, they repel. All right, so 40 degrees west minus 10 degrees west will give us 30 degrees. So that's just your theta. Okay, but our file is the common. They are both found on common latitude. It means our file is the common latitude is 60 degrees north. So we've been able to know what theta and phi is. So we can now substitute into the formula. So our distance PQ will be equals to theta. We have known it to be 30 all over 360 times 2 times pi is 22 over 7 times big R, which is the radius of the earth, 6,400, times the cos angle of phi, which is 60 degrees. All right, so we are going to have 30 times 2 times 22 times 6,400, and then the cos angle of 60 degrees. If you press your calculator, cos 60 is the same thing as sine 30, and that's 30 degrees. So cos 60 is 0.5. That's the value of cos 60. You can use the scientific calculator to verify that. All over 360 times 7, which is 2520. And so we are going to multiply all this. So that will be 30 times 2 times 22 times 6,400 times 0.5. So that gives us 4224,000. So we divide that by 2520, and so we are going to have 1676.19 kilometers. And so we've been able to calculate the distance between the two towns, P and Q. All right, so after calculating the distance, it's quite easy now to calculate your speed. Therefore, the speed, of course, speed is the rate of change of distance moved with time. So we calculate speed as distance divided by time. The distance is in kilometers and the time is in hours. So we've calculated the distance to be 1676.19. So we are going to divide that by the time. They said it took how many hours? 10 good hours. So we divide by 10. Kilometers by 10 hours. So we are going to have 167.6019 kilometers per hour. So that is the speed of that aircraft. We've divided the distance by the time to give us the speed, as simple as it is. So whenever you're asked to find the speed, you divide the distance by the time, because speed is the rate of change of distance moved with time. Thank you very much for watching our slide, Longitude and Latitude Part 2, which is the small circles. And in the next slide, when we will meet, we'll be taking the total length of the journey. When you're giving an aircraft or a bird flew from this town to another town, and then it changes its course to another town, we should find the total length of the journey and the speed of that bird or aircraft in kilometers per hour. That will be our Longitude and Latitude Part 3. We'll be meeting next. But please don't forget to subscribe to our video and to click on the bell notification. If you have any comment or any question, you can do that in the comment section and we'll get back to you to answer your questions. God bless you as you do that. Have a wonderful day. Cheers.